Hello! Today we're going to do some applied perimeter problems. So there are 3 perimeter questions to complete that will increase in difficulty. Feel free to pause the video and try each question for yourself, but they will get harder as time goes on. Alrighty, question number 1. Troy wants to purchase some fencing around his lawn. Fencing costs $14 per meter. How much will it cost to fence the lawn? If you want to try the question, now's your chance. Okay, so let's start working out the perimeter of this question. So first of all, let's try to fill in any sides that we're unsure of. So we know the left side over here will have to be 3 meters as well because it's a rectangle, and so will this side here. This will be 5 meters to match the other side on the right. But again, how do we find the 3 blank sides that we don't know? How do we find this side, and this side here? Well, if we just remember that the whole entire length of those 3 added together has to add to 8. Because this length here will match this length here. So if we add all these together, 3 plus 8 plus 3 plus 5 plus 5 plus the 8 from those 3 sides combined will give us 32 meters. Now we know that the fencing costs $14 per meter. So $14 times 32 is 448. So it'll cost Troy $448 for the fencing. Okay, question 2. If you want to pause the video and give it a go, now's your chance. Okay, we've been asked to calculate the perimeter of the shape below to 2 decimal places. So, there's a lot going on here. So, first of all, it looks like we have a giant rectangle, but it's had what appears to be a quarter circle cut out of it here, a quarter circle cut out of it here, and a half a circle cut out of it here. So, if we're going to find the perimeter of the shape, I suggest we break it into smaller sections. First of all, side A, which I'm calling this length here. This would be 7.5, take away this little segment here. Now, because of the dashes, I know this is 1.5. So 7.5 take 1.5 is 6 meters. Side B would be similar. It's 5 meters, but we're taking away the 1.5. So that should be 3.5 meters. Now, side C, I've called this curved section here, and it appears twice on this section here as well. So to work this out, we're going to have to find a quarter of a circumference and then times it by 2. So that's what I've done here. 1/4 times the circumference of a circle times 2, because there's 2 C's on the screen, gives us 4.7124. The next side here I call side D. Now I'm calling this section here and this section here combined to be side D. So how do we work this out? Well, we know the whole entire length here is 7.5 meters. But we can take off 1.5, which would leave us with 6, and then we can take off 4 here, which means these 2 D's added together must equal 2 meters. The next side I want to try to work out is side E, which is this curved section here. So we'll do a similar sort of thing we did for side C. We're just going to work out half of a circumference of a circle, because that's what we have, just half a circumference. And that will give us 6.2832 meters. And finally, the last side I'm trying to work out here is side F, and this should be pretty straightforward. Again, it's just going to be 5 meters, take away 1.5 is 3.5 meters. So if I take all of those little sections and add them together, I'll find the perimeter, which is 25.9956. So to 2 decimal places, the perimeter for this weird shape is 26.00 meters. Alright, we're looking at question 3 now. So a graphic designer has designed the following logo for a company. Calculate the perimeter of the logo to 2 decimal places. Now this is the hardest question of the 3. If you want to pause and give it a go, now's your chance. Alrighty, the first thing I want to do is find these matching sides here, side W. Now we can see from the little symbols next to the W that these 2 sides are exactly the same length. So how do we work out side W? Well, we're going to use Pythagoras theorem. Now, the reason we can use Pythagoras theorem is because this is an isosceles triangle here. That means that this height is exactly halfway in between. So halfway of 40 is 20. So this side is 20 squared, and then we're adding 20 squared, and we can use Pythag to work out W, which in this case is 28.2843. The next side I want to work out is side X, and we're going to use Pythagoras theorem for this again. So what we need to do is we'll need to add some lines here. Now the reason we can add lines like I did here is because these sides are matching each other from the same symbols, which means that this distance here and this distance here are exactly the same. So to find out that distance, we're going to take the whole length of 40 We're going to take off this 30 here, which means there's 10 millimeters left over. Now, this section here plus this section here has to add to 10, but we know they're both the same, which means both of them are 5 millimeters each. So this is 5 millimeters and then 20 millimeters here. So we can just use Pythagoras theorem and we'll end up with 20.6155 meters for x. Next thing I want to work out is y, which is this little section here. Now this is half a circumference, and we know the radius is going to be half of 10, which is 5. So I'm going to do half times 2 times pi times 5, which is just half of a circumference. So that's 15.7080 meters. The last shape I want to work out is side z here, and this is pretty easy to work out because if we know this whole length is 30, and we know that's 10 and that's 10, we're just going to go 30, take 10, leaving us with 10 meters. So now that we know all the individual sides, all we have to do is add them together. So we had 2 lots of w plus 2 lots of x plus 2 lots of y plus 1z right at the end. So this will add to 139.2156 millimeters, which rounds to 139.22 millimeters. Thanks so much for watching. Hopefully you were able to follow along with the questions. I know they got harder over time, but I'm trying to push you towards some of that trickier stuff so you grow in your confidence. Hope you guys have an awesome day.